Okay, here we will talk about IPsec protocol. We have two protocols description. One is about authentication headers edge. This protocol is from the IFC 4302. It actually provides source authentication and data integrity, but not confidentiality. The other is related to the encapsulation security protocol. It's RFC 4303. It provides source authentication, data integrity, and confidentiality. Confidentiality. More widely used than Edge. So, related to the security authentication, before sending the data, security authentication SA, security authentication association established from sending to receiver entity. Actually, it's duration. So you can see this duration from the source to destination before the sending data. And before the sending data established from sending to receiver entity. So it's duration from the source to destination, from source to the destination, security association. So ending receiving the entity maintain the state information. Before about the SA, recall the TCP endpoint about the maintain state information. So TCP is the endpoint also maintain the state information. The other is IP connectionless. It's IPsec. It's connection oriented. So it's based on IPsec. It's connected orientation. So it's a duration is considered a durational. So you can see is R1 store for SA. So the R1 stores for SA is a 32-bit identity. Security parameter index, we call the SPI, security parameters index. Original SA interface is 200 is from here. Source is 200 IP dot 168 and 0.1 and 0.100 to the destination. So SA interface, you can see the interface IP here. So the SA basically you have to enter the IP address of the interface. The other the destination IP address interface is here 193.68 and 2 and 23. So type of encryption used and the encryption key, then the type of integrity check used and the authentication key. So you can see the IPsec datagram is a ESP header, is an encryptor here. So encryptor including the original IP head, HDR, original IP datagram payload, and the ESP trail. And the trail ESP is three portion is pending and the pending length, then the next header. So the tunnel mode ESP is include the authentication and the encrypt. The ESP authenticated here and the ESP header, then the new IP header. So ESP trailer pending for the block cyber. So ESP the trailer is here, this portion of the green. Including the pending and the pending list and the next header. Then ESP header is a two portion. One is the SPI. Then the other is the sequence number. So SPI or the receiver entity know what to do, and the secret number is the relay attack, replay the attack. So the MAC in ESP authentication field creates with the shared secret key. Okay, so overall is a tunnel mode ESP. So ESP tunnel, you know, is a encryption here, and then over the header here. So R1 is a payload from here, so it's sent to here is payload, then the need the over header here. So overall, the SA is the ESP header and the ESP authentication. Then based on this SA. So and R1 is appended ESP trailer to original datagram, which includes original header field. Encrypts the result using an algorithm key specified by SA. So this encryption by SA, then using the algorithm key specified by SA. So append the ESP header to find over this encryption quantity. Creates authentication MAC using the algorithm and the key specified in SA. So append the MAC forming the payload. Create a new IP header field and addressing to the tunnel endpoint. Okay, so overall is like here, at R1 is the ESP trailer, and the specific algorithm using the algorithm and the key specified by the SA, and the ESP header, and the encryption quantity, and the MAC using the algorithm and the key in SA. So it's append the MAC from the payload and create a new IP header, and the new IP header field address to the tunnel endpoint. So IP sync the sequence number is the initial the new SA send the initial the sequence number from the to the leader. So it's the initialization the sequence number is leader. Each time datagram is sent on SA, so center increment the sequence number count. So place value in sequence field. The goal prevent the attack from the sniffing and replanning a packet. So the recipient of the duplicate, the authentication, the IP packet may be the disturb the service. So master the destination check for duplicate. Then keep track of all received the packet instead of using the window. Then IPsec security the database. The security policy database, SPD, the policy database. The policy for given datagram sender need to know if it should be used the IPsec. So policy stored in security policy database. So policy actually is stored in SPD. And need to know which SA to use. May use the source and the destination IP address, protocol number. So SAD, how to do, and the SPD actually is what to do. So SAD is a security authorization database. SPD is a security policy database. SPD is what to do because it's policy. So endpoint hold the SA state in security authentication database as SAD. Then when sending IP sync datagram R1 accessible the SAD to determine how to process the datagram. Then when the IP sync datagram arrive through R1 from R1 to R2, R2 is sent SPI in IP single datagrams index the SAD with SPI processing and datagram accordingly. So it's a S security authentication associated database. So summarily, the IP security, the service truly actually sits somewhere between the R1 and R2. It actually is from the source and the destination. So she doesn't know the key. So Trudy will be able to see original content of the datagram. So how about the source and the destination IP address and the transport protocol application port? So free bit without destination and the masquerade as R1 using R1's IP address replay the datagram. So basically, the internet key exchange IKE. Previous example is the manual establishment of the IPsec SA in IP security endpoint. Example SA is the SPI number and the source IP here and the destination IP here. The protocol use because need the security, so using the ESP encryption algorithm is the 3DS and the CBC. So HMAC algorithm is MD5. Encryption key here, using the encryption key, and the HAC key here. So middle key is impractical for the VPN with the 100 seconds of the endpoints. So instead of the use IP internet key exchange. IKE IP key exchange, we have two keys. One is PHK, the other is PKI. Is follow is the authentication proof who you are with either. Please share the secret. Please share the secret PHK or with the PKI, public or private key. And the certificate. So the PSK pre-share the secret. Both sides has start with the secret. So run the IKE to authenticate with each other and generate IP sync SA, one in each direction, including the encryption authentication key. So PKI, both sides start with the public key and private key pairs. Certificate run IKE to authenticate each other, obtain the IP sync SA, one in each direction. Similar with the handshake in SSL. So here is probably pre-share the key secret and the public key and the private key security, the PKI, public key and the private key pair. So IKE phase, the IKE has two phases. Phase one established by duration IKE SA. Then number one IKE SA different from the IP security SA. And the AKA IS AKMP security association. Phase two is the IS AKMP is used to security negotiable the IP sync pair of the SA. Phase one has two modes, aggressive mode and main mode. Aggressive mode use the field message. Main mode provide identity protection is more flexible. So IP sync summary, the IP secure message is changed for algorithm. security key the SPI number. So either edge or ESP protocol or both, the edge provide the integrity and the source authentication. ESP protocol with edge additional provide encryption. So IP security peers can be to and system to routers or to firewalls or the router firewall and the end system. So IP security summary, the IP IK message is changed for algorithm. The change algorithm is changed for algorithm security and SPI number. Is neither is changed the IK message. Second is either edge or ESP protocol, or both. Edge provide integrity source authentication. ESP protocol with edge additional provide encryption. Encryption is from ESP protocol. So IP security peers can be two end system, two routers, two firewalls, or one end router or the firewall. For example, is wireless mobile from the AP and the authentication server, encryption and the authentication wireless. A writing mobile mask authentication with access point establish communication over the wireless link, authenticator to the network. So first step, the mobile discovery of the security establishment, establish the AP and from the authentication server. Then discover of the security capability. AP advertised its presence from our authentication and the encryption provided. Device requests a specific form authentication encryption design. Although the device AP already exchanged the message, device not yet authentication authenticated does not have any encryption key. The second authentication sent to the mutually authentication key deviation. Deviation and mutually authentication and share the symmetry the key deviation. Then as authentication server, the mobile already have a shared common secret, like a password. Then as a mobile uses shared secret key and numbers, numbers is a random number, prevent the unrelated attack, cryptography. And hashing, ensure the message integrity to authentication each other. Then as and the mobile derive the symmetric session key. So WPA3 is a handshaking from the mobile and the authentication server. First, the authentication server sends the numbers from the authentication server is a random number. The numbers is a random number from the authentication server as generated the numbers random number sent to the mobile. So you can see the derive the session key between the key mobile and the authentication server using the initial shared key secret numbers is from the created generated authentication server is the numbers and also the numbers on the mobile and sent to the B is numbers mobile, including the HMSC its FO function the authentication server and between the mobile key and the numbers from the authentication server. So mobile receive the receive the numbers of from the authentication number, then generate the numbers of a mobile. So in this moment, generate symmetric shared session key between the mobile and the authentication server key using the numbers of the from the authentication server and the numbers from the mobile and the initial shared key. So send the numbers of the mobile here, and the HFAC assign value using the numbers of the authentication server and the initial share the secret. And the C step, you can see actually in this moment is divide the session key between the numbers of mobile and of the key between the mobile and the authentication server, the key using the initial share key and the numbers of authentication server and the numbers of mobile. So WAP3, the authentication and the encryption is authentication server in this moment is from the AP to the mobile. In this stage is discovering the security capability between the AP and the mobile. And step 2 is from the authentication server maybe skip the AP or the direct from the AP is to the mobile. Is virtually authentication the key deviation is actually between the authentication server and the mobile. Somehow it may be skip the AP. Then build out the AP between the AP and the authentication server in these two connections, and the authentication server sent to the AP, and share the symmetric session distribution like the AES encryption to the AP. Then share the key divide at the mobile and AES. Then AES inform the AP of the shared symmetric session. And in 4 steps, the AP between the mobile, then encrypt the communication over the Wi-Fi. So encrypt the communication between the mobile, remote host via the AP, the same key derived and the mobile and the access authentication server. So the authentication server inform the AP of this share symmetric session. So you can see this protocol authentication encryption is from the authentication server and to the mobile, the AP and the wireless network is a EAP TLS between the mobile AP and the wireless network authentication, and then the EAP and then based on the wireless 802.11, then use the UDP IP and the radius over the UDP IP, the EAP over the LAN, the EAP OL, then EAP over the LAN, then EAP or TLS over the EAP. So EAP is tensionable the authentication protocol. Because EAP is tensional authentication protocol over the radius and over the LAN. So EAP is from RFC 3748 define end-to-end request and response protocol between the mobile device and the authentication server. So authentication and the encryption in 4G LTE, we have the home subscriber service HSS home network to the mobile management entity is from the this network and to the base station. It's a mobile access from to the base station. Arriving the mobile master or associate associate with the base station establish communication over the 4G wireless link. So authenticated itself into network, authenticated the network. Notable the different from the Wi-Fi. So mobile actually is from the SIM card. So SIM card provide a global identity and contain the share key. So SIM card store the global identity and share the security key. And the service in the VT network here is depend on pay service subscription in the home network. So the VT the network is the access database on the home network. It's to the management the base station. And the base station the mobile access wireless network, wireless communication to the base station. So in this moment, between the base station and the mobile must be created a key. So the authentication encryption in 4G LTE, the key between the base station and the mobile is the key derived. And the mobile also build our HSS and the mobile key. So it's two keys. One is the base station and the mobile is the key. Between the base station and the mobile key. The other is the HSS, the home subscriber service and the mobile key. So mobile have the base station use the derived session key. Derived session key, the key between the base station and the mobile to encrypt the communication over 4G link. Then the MME beta network and plus the HSS home network together play a role with the Wi-Fi access. So it's ultimate authentication in HSS is shared with the mobile key together. So trust business relationship is between the meter and the home network. So we can see in these steps. So first steps, the mobile access edge attached to the base station. The base station attach the MME, the mobile management entity. Then go to the from the MME network to the home network, the authentication request, the IMSI and the VN name, VN information to the HSS, the home subscriber service home network. So authentication request to the home network HSS. The mobile sent to the attached message, including the IMSI and the VN network information. So relays from base station to the VN MME to home HSS. So IMSI identify the mobile home network. Then in these steps, the B from the home network sent to the authentication response, the authentication token response the HSS and the key. So HSS use the share in advance, share the key, share the in advance secret key between the HSS and the mobile key to derive the authentication token is the authentication token, and the expansion the authentication response the token, expansion the response authentication token. So authentication token contain the info the encryption from the by HSS here. HSS using the between the mobile key and the HSS key allow the mobile to know that whoever compute the authentication token know the share in advance security key. So mobile has authenticated the network And with the HSS keep the security, pre-share the HSS from later use. Then in C steps, the mobile get the authentication token from the authentication response. The authentication token is patient the response HSS and the key. From the host network, the C authentication response from the mobile response the mobile. The mobile computer response. The mobile using its secret key to make the same cryptographic calculation like the HSS mobile made to compute the expression response HSS and sends response of the mobile to MME in these steps to the MME. This moment, the MME response and in these steps confirm the response of the mobile and then send okay, its key is correct and from these steps and then send to mobile and mobile is authentication by the network because it's also authorized from the HSS to the MME, the lead network get authorized to confirm the response from the mobile here the second key from the D steps, the OK and the OK to the mobile. Mobile authenticate in this moment is authenticated by the network. The MMS compare the mobile computer value the response of mobile with the HSS computing value here and then here and to here. So if the late match, the mobile authentication is correct. The MMS inform the base station that the mobile is authenticated, generate the key for the base station. So key actually is a deviation between the base station and the mobile. The key deviation here. So in each steps, the mobile and the base station determine the key for encrypting the data control frame over the 4G wireless network, and the AES can be used. So authentication encryption from the 4G to 5G. The 4G MME in this network makes authentication decision. The 5G actually home network provide the authentication duration and make a decision. The video MME play the middle man. So it's the middleman rules can be the still reject. The 4G share the in advanced key, so 5G key not share in advance for the IoT device. The 4G device, the IMSI transmit in the clear text to base station. In the 5G, the public key crypto use the crypto IMSI. So in the firewall is also is the isolate organizations internal network from large internet allows some packet to passes blocking the others. So firewall is a block the underneath the network and the public internet. So in the public internet is an untrusted network is somehow maybe a big guy. And the firewall is control is a trusted network. The administrator network is a firewall based on the firewall is isolated organize the internal network from the large internet. So it's allow the sub-packet pass of blocking. So firewall while prevent the is a denial of the service attack. So it's a SYN forwarding attack established, and also prevent the illegal verification and allow some authentication access in inside network and the three type of firewall network